Assalamualaikum warahmatullahi wabarakatuh. Example 16. So we will deals with the peak heat flux in nucleate boiling. So when we have the maximum heat flux and then we combine with the nucleate boiling equation. So this is the question. Water in the tank is to be boiled at sea level by 1 centimeter diameter nickel plate steel heating element equipped with electrical resistant wires inside, as shown in figure 10.6. So that means the maximum heat flux that can be attained in the nucleate boiling regime and the surface temperature of the heater in that case. So water in the tank to be boiled at sea level. We know that the sea level is at 1 atm, and then therefore we know that at 1 atm the water will boil at 100 degrees Celsius. So now we do not know what is the surface temperature of our electrical resistant wires. Therefore, that is what the question asks us. Now, the first one, we have to calculate what is the maximum temperature. It is actually, we have to determine what is the maximum temperature before we can determine what is the surface temperature. So that's why the equation arrangement, the question arrangement is like that. Okay, you have to determine what is the maximum heat flux, and then after that, you can calculate the surface temperature. Now, we have to take a look at the maximum heat flux first. So at maximum heat flux equation is this one. So Q dot maximum is equal to CCR HFG surface tension G rho square V rho liquid minus rho vapor to the power of 1/4. So now what we have to do, the first one, we have to determine what is the CCR value. So before we determine the CCR value, you have to find what is the properties of what is the value for the properties of HFG, rho liquid and rho vapor. So that is and surface tension. You will refer all these properties at T saturation. Okay. The properties of water at saturation temperature 100 degrees Celsius are, so for the surface temperature, for the surface tension, you will refer to the table 10.1. Okay, at 100 degrees Celsius, you will have 0.0589 Newton per meter for your surface tension. And then the other properties will be referred to saturation temperature at 100 degree Celsius. So now to determine what is the maximum, we go for the maximum temperature first. We already determined all these properties, and then we have to determine what is the value of CCR. As I mentioned before in the previous video, CCR will be determined from table 10.4. So now what we have to do is to determine what is the heater geometry. So now take a look at this question. The heater geometry will be in what? In cylinder, because the electrical resistance here is in cylinder. Therefore, we are only referring to these two value. Okay, cylinder, and after this we will see either it is falls under large or small horizontal cylinder. So that is the first one. Second one, we have to determine what is the value of L. So substitute the value here. Okay, take out this equation and then substitute all the values to get what is the L star. So I get the L star is my L star is 2.0, okay, which is greater than 1.2. So 1.2, I will erase this first. So my L star value is 2.0, which is greater than 1.2. Take a look at this L. So we will refer only this to L because we have cylinder geometry. So L star, which is greater than 1.2, is here. So take a look at here and then take a look at this value. So our value for the CCR is 0.12. So our CCR is 0.12. Okay. So our CCR value is 0.12. So after that, substitute the value of properties into the Qmax equation, and you will get the Qmax is 1.017 times 10 to the power of 6 watt per meter squared. So substitute into this equation. You already get your CCR value is 0.12. Substitute into this equation, HFG, all of these properties, substitute, and then you will get what is the Q maximum. So my Q maximum is 1.017 times 10 to the power of 6 watt per meter square. Since that equation is too long to write it down, and that's why I only give you the value, okay, the end value or the maximum, that Q dot maximum. Okay, you have to calculate by yourself. Substitute all the values, all the properties inside that equation. So after that, what we have to do, this question asks us what is the surface temperature of the heater. So how we are going to solve this surface temperature? How do we find the surface temperature? We know that equation is if we substitute the delta T excess in the nucleate boiling, we will get the same value Q dot nucleate at maximum, the same as the Q dot maximum. If we substitute, and then we know that when we substitute into this equation, the graph will tabulated and then the curve will have at maximum. So at this maximum, Q dot nucleate can be equate, okay, can be equate with Q dot maximum equation. So what you have to do is you have to equate Q dot nucleate with Q dot maximum equation. But you do not have to worry because you already find what is the Q dot maximum. So what you have to do now, find the properties here. So we have CSF, we have N. So all the properties will be evaluated at 100 degrees Celsius, T saturation. Now we take a look at CSF and N value. So to get what is the value for both of these parameters, we have to refer to table 10.3. So take a look at the question, water in the tank. So we have fluid, water, and then we have steel heating element, nickel plate steel heating. So nickel plate, okay. Take a look at water and then nickel. So our fluid heating surface combination is water nickel. Do we have another other nickel? No, water nickel. So take a look at the value for the CSF. So we will get 0.0060 and the value for the N is 1. So that is why your properties, your CSF and N value is 0.0060 and 1.0. So after that, substitute all the values, and now we know that the TS is remain unknown. We do know about the T saturation, but we do not know about T surface. So rearrange the equation and you will get that this equation is equal to Q dot maximum. So Q dot maximum is already calculated before, and then rearrange this equation, you will get what is the TS. Okay, from that calculation, we will get your TS. So you will equate Q nucleate equation with Q dot maximum. Okay, and then you will get your T surface equal to 119 degree Celsius. Okay, this is T surface at maximum heat flux. Okay, T surface at maximum heat flux, not the T surface for the entire for nucleate boiling regime. Okay, this is T surface at maximum heat flux. Okay, so you have this graph, and then actually, okay, this equation here, as you can see here, this is actually delta T excess. Okay, from here we know that what we find here is delta T excess. So this delta T excess is T surface minus T saturation, which means this Ts is the same as this Ts, which is this Ts value lah. Okay, delta T excess at this. Okay, Ts here is Ts at maximum. Okay, that's all. Thank you.